Okay, in this video I'm going to do the 5.3 notes, and we're doing angle bisectors of triangles. So an angle bisector is a ray, so type in ray, that divides an angle into two congruent and adjacent angles. Okay, and this, if you want to read more about this, you can look in your textbook. We're on page 312. Okay, the point of concurrency of angle bisectors. Point of a triangle where all of the angle bisectors intersect. This point is now called the in-center. Okay, so the in-center is where the angle bisectors intersect. And remember, previously we talked about the circumcenter, and that was where the perpendicular bisectors intersected. Okay, so you're inside a triangle for this, and I'll have a picture of this a little further down the page. Okay, so the distance from a point to a line, that's going to be defined as the distance of the perpendicular segment from the point to a line. And again, I'm going to show you this in just a second. Actually, you can look at it right here. This point, D, is on the angle bisector. So this distance from D to B is a perpendicular distance. Okay, so that's what they're speaking about here. They are referring to distances like this that form right angles. This one does the same thing. Okay, so then let's talk about the theorem here. If a point is on the bisector of an angle, then what happens is a couple of things. First off, the angle bisector itself divides this angle A into two equal pieces. Then if a point is on the angle bisector, what happens is the distance from that point, so the perpendicular distance from B to D, equals the perpendicular distance from D to C. Okay, so that's what's resulting. And that's all spelled out here. Okay, let's go to our next page. Okay, so the converse of the angle bisector is this. If you see that this point D is equidistant from B as it is from C, then you know, okay, that guy must be on the angle bisector. So once you see this, so you see these right angles and equal signs of those two segments, then you know this and this has happened. Here is the concurrency of all the angle bisectors. Okay, so the angle bisectors are in red. Okay, so they're all in red. So that means that this angle was bisected into two equal parts. And I'm not going to do the others because it's too small to be able to do it. Well, I guess I could make it bigger. Okay, so this is going to be equal to this. And then this is going to be equal to this. Okay? Here is your in-center. And what happens when they all connect is I get this piece equal to this piece equal to this piece. Okay? So that's what's going on inside the triangle. So when you have all three connect, you have a series of resultant measurements. So if I give you the measurement for DP, you then know PE and PF. So that's all written here. So now let's try to apply some of this. And once again, the other thing I want to stress is that this point P in the middle is called an in-center. Okay, so this is a pretty easy topic. So let's look on the next page so we can see an example. So here's an example. It's find the measure of GFJ. So what am I seeing? I am seeing that the distance from J to H and the distance from J to G is exactly the same. Therefore, I know that angle F has been bisected. So this is also 42. So GFJ is going to equal 42 degrees. Okay, look at this goalie problem. A soccer goalie's position relative to the ball and goalposts forms congruent angles as shown. Okay, so that's an angle bisector. So what do I know? I know that this little guy is standing on the angle bisector, and therefore his distance to either side is going to be exactly the same. Okay, so now let's read the problem. Will the goalie have to move farther to block a shot toward the right goalpost R or the left goalpost L? So the answer is no. It's the same distance. Same exact distance. And we know that because he is standing on the angle bisector of angle B. Okay, we have one more problem to do. We'll do that on the next page. Here is another example. So use algebra to solve a problem. For what value of x does P lie on the angle bisector? Okay, so if this is going to be on the angle bisector, what has to happen? This has to equal this. So let's see what value makes that true. So we're doing a little bit math. Okay, subtract x. So now I have 2x minus 1x. Hang on, let me go back. So this is just 1x minus 1 equals 3. Add 1. 4 equals x. So the value should be 4, but let's just check our work. If x is 4, this is 7, and this is 7. Bingo. So that works. Okay, and that completes the notes and the example for 5-3.